In 1942, near the besieged city of Sevastopol, German soldiers assembled a weapon so large that many who saw it for the first time did not believe it could actually fire. It did not resemble a normal artillery piece. It did not resemble a normal train. It looked like a piece of industrial infrastructure placed on railway tracks by mistake. This was the Schwerer Gustav, an 800mm railway gun, the largest artillery weapon ever built and used in combat. Its barrel was longer than many buildings. Its shell weighed as much as a small truck. It required thousands of men, special rail lines, cranes, and days of preparation for a single firing sequence. And yet, it was real. The idea behind it was simple in theory and absurd in practice. Build a gun so powerful that no fortress in the world could resist it. A weapon capable of destroying reinforced bunkers, underground ammunition depots, and concrete defenses from tens of kilometers away. A gun that did not need to approach a target. A gun that could sit far beyond the horizon and still reach it. When the project began, even experienced artillery engineers doubted whether such a machine could be constructed. The mathematics worked, the metallurgy was possible, but the scale pushed the limits of logistics and engineering. Moving it was a problem. Aiming it was a problem. Firing it without destroying itself was a problem. But Germany built it anyway, and in the summer of 1942, it was transported piece by piece to Crimea to take part in the siege of Sevastopol, not as a symbol, but as an operational weapon. The soldiers who assembled it were not looking at a cannon. They were looking at an engineering experiment that had somehow become part of a real war. To understand why the Germans built the Gustav, you have to go back before the war even started. In the late 1930s, German military planners were studying the massive French border fortifications known as the Maginot Line. These were not simple bunkers. They were deep, reinforced underground complexes made of thick concrete and steel, designed to survive conventional artillery and bombing. Standard weapons were not enough to destroy them. The conclusion some engineers reached was extreme. If normal artillery could not break these fortresses, then an entirely new kind of artillery had to be created. A gun so powerful that no fortress in the world could resist it. A weapon capable of destroying reinforced bunkers, underground ammunition depots, and concrete defenses from tens of kilometers away. A gun that did not need to approach a target. A gun that could sit far beyond the horizon and still reach it. When the project began, even experienced artillery engineers doubted whether such a machine could be constructed. The mathematics worked, the metallurgy was possible, but the scale pushed the limits of logistics and engineering. Moving it was a problem. Aiming it was a problem. Firing it without destroying itself was a problem. But Germany built it anyway. And in the summer of 1942, it was transported piece by piece to Crimea to take part in the siege of Sevastopol, not as a symbol, but as an operational weapon. The soldiers who assembled it were not looking at a cannon. They were looking at an engineering experiment that had somehow become part of a real war. To understand why the Germans built the Gustav, you have to go back before the war even started. In the late 1930s, German military planners were studying the massive French border fortifications known as the Maginot Line. These were not simple bunkers. They were deep, reinforced underground complexes made of thick concrete and steel, designed to survive conventional artillery and bombing. Standard weapons were not enough to destroy them. The conclusion some engineers reached was extreme. If normal artillery could not break these fortresses, then an entirely new kind of artillery had to be created. A gun so powerful that no fortress in the world could resist it. A weapon capable of destroying reinforced bunkers, underground ammunition depots, and concrete defenses from tens of kilometers away. A gun that did not need to approach a target. a gun that could sit far beyond the horizon and still reach it. When the project began, even experienced artillery engineers doubted whether such a machine could be constructed. The mathematics worked, the metallurgy was possible, but the scale pushed the limits of logistics and engineering. Moving it was a problem, aiming it was a problem, firing it without destroying itself was a problem. But Germany built it anyway, and in the summer of 1942, it was transported piece by piece to Crimea to take part in the siege of Sevastopol, not as a symbol, but as an operational weapon. The soldiers who assembled it were not looking at a cannon. They were looking at an engineering experiment that had somehow become part of a real war. To understand why the Germans built the Gustav, you have to go back before the war even started. In the late 1930s, German military planners were studying the massive French border fortifications known as the Maginot Line. These were not simple bunkers. They were deep, reinforced underground complexes made of thick concrete and steel, designed to survive conventional artillery and bombing. Standard weapons were not enough to destroy them. The conclusion some engineers reached was extreme. If normal artillery could not break these fortresses, then an entirely new kind of artillery had to be created. A gun so powerful that no fortress in the world could resist it. A weapon capable of destroying reinforced bunkers, underground ammunition depots, and concrete defenses from tens of kilometers away. A gun that did not need to approach a target. A gun that could sit far beyond the horizon and still reach it. When the project began, even experienced artillery engineers doubted whether such a machine could be constructed. The mathematics worked, the metallurgy was possible, but the scale pushed the limits of logistics and engineering. Moving it was a problem, aiming it was a problem, firing it without destroying itself was a problem. But Germany built it anyway, and in the summer of 1942, it was transported piece by piece to Crimea to take part in the siege of Sevastopol, not as a symbol, but as an operational weapon. The soldiers who assembled it were not looking at a cannon. They were looking at an engineering experiment that had somehow become part of a real war. To understand why the Germans built the Gustav, you have to go back before the war even started. In the late 1930s, German military planners were studying the massive French border fortifications known as the Maginot Line. These were not simple bunkers. They were deep, reinforced underground complexes made of thick concrete and steel, designed to survive conventional artillery and bombing. Standard weapons were not enough to destroy them. The conclusion some engineers reached was extreme. If normal artillery could not break these fortresses, then an entirely new kind of artillery had to be created. A gun so powerful that no fortress in the world could resist it. A weapon capable of destroying reinforced bunkers, underground ammunition depots, and concrete defenses from tens of kilometers away. A gun that did not need to approach a target. A gun that could sit far beyond the horizon and still reach it. When the project began, even experienced artillery engineers doubted whether such a machine could be constructed. The mathematics worked, the metallurgy was possible, but the scale pushed the limits of logistics and engineering. Moving it was a problem, aiming it was a problem, firing it without destroying itself was a problem. But Germany built it anyway, and in the summer of 1942, it was transported piece by piece to Crimea to take part in the siege of Sevastopol, not as a symbol, but as an operational weapon. The soldiers who assembled it were not looking at a cannon. They were looking at an engineering experiment that had somehow become part of a real war. To understand why the Germans built the Gustav, you have to go back before the war even started. In the late 1930s, German military planners were studying the massive French border fortifications known as the Maginot Line. These were not simple bunkers. They were deep, reinforced underground complexes made of thick concrete and steel, designed to survive conventional artillery and bombing. Standard weapons were not enough to destroy them. The conclusion some engineers reached was extreme. If normal artillery could not break these fortresses, then an entirely new kind of artillery had to be created. A gun so powerful that no fortress in the world could resist it. A weapon capable of destroying reinforced bunkers, underground ammunition depots, and concrete defenses from tens of kilometers away. A gun that did not need to approach a target. A gun that could sit far beyond the horizon and still reach it. When the project began, even experienced artillery engineers doubted whether such a machine could be constructed. The mathematics worked, the metallurgy was possible, but the scale pushed the limits of logistics and engineering. Moving it was a problem. Aiming it. The ammunition for the Gustav did not resemble normal artillery shells. Each one was over 7 meters long and weighed close to 7 tons. Moving a single shell required cranes, rails, and careful coordination. It was less like loading ammunition and more like transporting industrial equipment. There were different types of shells for different purposes. One was designed to penetrate deep into reinforced concrete before exploding, a bunker buster intended to destroy underground fortifications. Another carried a high explosive charge meant to devastate surface targets across a wide area. These shells were so large that they had to be stored and transported on specially built railway cars. Bringing them to the gun was a slow, deliberate process. Every movement had to be precise. When a shell was finally lifted into position, it was guided into the breach with mechanical assistance. The loading process alone could take close to an hour. This meant that each shot was not part of rapid artillery fire. It was an event. The entire crew prepared for it. Calculations were double-checked. Rail alignment was verified. Weather conditions were considered. The gun had to be elevated and positioned with extreme care because adjusting aim after loading was difficult and time-consuming. Each shell represented hours of preparation and the work of dozens of people, and when it finally fired, the effect was unlike anything else on the battlefield. When the Gustav fired for the first time at Sevastopol, the sound did not resemble normal artillery. It was closer to an explosion happening at the gun itself. Witnesses described a shockwave that could be felt hundreds of meters away. Dust and debris fell from nearby equipment. The ground trembled. Even experienced artillery crews were startled by the force released when the shell left the barrel. Then there was silence, because the shell took nearly a full minute to reach its target. 47 kilometers away, Soviet defenders had no immediate warning. There was no aircraft overhead, no artillery battery visible on the horizon, only a sudden, enormous impact as a 7-ton projectile smashed into their defenses. The shell did not explode on contact. It buried itself deep into rock and concrete before detonating underground, sending shockwaves through tunnels and fortifications that had been designed to withstand conventional bombardment. The effect was devastating. Positions that had survived days of regular artillery fire were suddenly vulnerable to a weapon that could reach them from beyond sight, beyond sound, beyond anything they could respond to directly. For the German crew, the moment was both impressive and unsettling. They had fired a weapon so powerful that the target was invisible to them. They had no immediate feedback, no smoke plume to watch, no visual confirmation. They had to rely on observers far away to report what the shot had done. The Gustav did not behave like a cannon. It behaved like a distant earthquake triggered by machinery. Sevastopol was not an ordinary city to besiege. Much of its defensive strength was underground. Ammunition depots, command centers, and storage facilities had been carved into rock, protected by layers of concrete and earth. These were not targets that could be easily destroyed from the air or by standard artillery. Bombers could hit the surface, regular guns could damage outer structures, but the deepest facilities remained intact. This is where the Gustav finally justified its existence. German observers identified specific underground targets that had resisted every other form of attack. Coordinates were calculated carefully. The Gustav was aimed not at buildings, but at positions buried beneath them. When its shells struck, they did not simply explode on impact. They penetrated deep into the ground before detonating, collapsing tunnels and destroying ammunition stores hidden far below the surface. In some cases, entire underground sections were rendered unusable in a single strike. One of the most famous targets was a Soviet ammunition depot built into rock cliffs along the harbor. Previous bombing and shelling had failed to disable it. The Gustav's shell penetrated the rock and detonated inside, triggering secondary explosions that continued for hours. For the first time, Soviet defenders faced a weapon that could reach places they believed were untouchable. The Gustav was not useful against moving troops or open battlefield targets, but against deeply buried fortifications, it had a capability no other weapon at the time could match. A normal artillery piece can be turned by a few men, adjust the angle, shift the wheels, fire again. The Gustav did not turn. It could not pivot left or right in any meaningful way. Its enormous size and weight meant that aiming horizontally required moving the entire weapon along curved sections of railway track that had been built specifically for this purpose. To change direction, the crew had to roll the gun slowly along a pre-laid arc of rails. This was not a quick adjustment. It was a careful operation involving locomotives, engineers, and constant communication. Every small movement had to be controlled to keep the structure stable and aligned. Vertical aiming, adjusting elevation, was easier, but still required massive mechanical effort. The barrel had to be raised and lowered by heavy systems designed to handle its immense weight. Because of this, every shot required planning in advance. There was no rapid correction after firing. If the aim was slightly off, correcting it could take hours. Calculations had to be precise before the shell was even loaded. Observers near the target relayed information back to the gun crew after each impact. Only then could adjustments be made for the next shot. This turned the Gustav into a slow, deliberate weapon. It did not respond quickly to battlefield changes. It did not adapt to moving targets. It operated on a schedule measured in hours, not seconds. The battlefield had to wait for it. The Gustav was too big to hide. From the air, it was impossible to mistake for anything else. A long metallic structure stretching across railway lines, surrounded by activity, cranes, rail cars, and hundreds of personnel. Even without knowing exactly what it was, Soviet reconnaissance could see that something enormous was operating near the front. This made the gun an obvious target. To protect it, the Germans had to build an entire defensive perimeter around the site. Anti-aircraft batteries were positioned nearby, fighter patrols were assigned to watch the skies, camouflage nets were used as much as possible, though hiding something of that size was never realistic. Security units guarded the area constantly. The site resembled a fortified base more than an artillery position. Every time the Gustav prepared to fire, it risked revealing its exact location through the smoke, noise, and visible activity. Soviet aircraft could potentially follow the signs and attempt a bombing run. So firing the gun was not just an artillery action, it was a moment when the entire defensive network had to be ready. The irony was clear. A weapon built to destroy fortifications needed its own fortification just to survive long enough to be used.
The Gustav did not fire in bursts. It fired in appointments. From the moment a target was selected, the process could take hours before a single shot left the barrel. Calculations were performed, rail alignment was checked, the barrel elevation was adjusted, the correct shell was brought forward on rail cars and lifted by crane. Then came the loading. The shell had to be moved carefully into the breech using mechanical systems. Every movement was slow and deliberate. Once in place, final checks were performed across the entire structure to ensure nothing was misaligned or under stress. Only then could the firing sequence begin. When the order was given, the crew moved into prepared positions. The gun discharged with enormous force. Then, everything began again from the start. This meant the Gustav could fire only a handful of rounds per day. Compared to conventional artillery batteries that could fire dozens or hundreds of shells in the same time, the Gustav was incredibly slow. Its power came not from rate of fire, but from the effect of each individual shot. Each firing was the result of hours of preparation and the coordinated effort of hundreds of people. The Gustav was not an instrument of rapid warfare, it was a machine built for singular, deliberate destruction. When the Gustav fired, the crew could not see what they were hitting. The target was far beyond the horizon, hidden by distance and terrain. There was no immediate visual feedback, no explosion to observe through binoculars. After the thunder of the shot, there was only waiting. Observers positioned near Sevastopol were responsible for reporting the results. They watched for impact points, smoke, debris, and changes in Soviet defenses. Messages were sent back by radio describing what had happened. Only through these reports did the gun crew learn whether the shell had struck its intended target. This delay added to the strange nature of operating the weapon. Unlike traditional artillery where gunners could adjust fire based on what they saw, the Gustav relied on distant eyes and careful communication. Corrections could take hours between shots. For the crew, it felt like launching a projectile into the unknown and trusting that someone far away would confirm its effect. The connection between action and result was stretched across dozens of kilometers, turning each firing into a slow, almost abstract exercise in long-distance destruction. The gun did not feel like part of the battlefield. It felt detached from it, connected only by calculations and radio reports. At first, Soviet defenders in Sevastopol did not understand what they were facing. The impacts were unlike anything they had experienced before. There were no aircraft overhead, no visible artillery positions, no incoming sound that could be traced back to a source, just sudden, enormous detonations that seemed to come from nowhere. Shells were penetrating deep into rock and concrete before exploding underground, collapsing tunnels and storage areas that had been considered safe. The pattern of destruction did not match bombing or standard artillery fire. It took time for Soviet commanders to piece together what was happening. Reconnaissance reports eventually revealed unusual rail activity far from the city. Observers noticed a massive structure assembled on tracks, surrounded by heavy defenses. Only then did the scale of the threat become clear. They were being shelled by something positioned so far away that counter-battery fire was impossible. There was no way to reach it with their own artillery. Air attacks were risky because of the strong defenses around the site. The weapon was simply too distant, too protected, and too large to neutralize easily. For the defenders, this created a sense of helplessness. They were under attack from a source they could neither see nor strike back at, a weapon that operated beyond the normal limits of the battlefield. Even while it was being used, the Gustav started to take on an almost mythical reputation among the soldiers who heard about it. Stories spread quickly through German ranks. A gun so large it needed 2 rail lines, shells the size of small cars, a weapon that could destroy bunkers from beyond the horizon. Many who had never seen it began to speak about it as if it were something unreal. The truth was impressive enough without exaggeration, but the scale of the machine encouraged imagination. Each time someone described it, the details seemed to grow larger. Some believed it could level entire cities in a single shot. Others thought it could fire endlessly without pause. In reality, the Gustav was slow, complicated, and demanding to operate, but perception did not follow practicality. To many soldiers, it became a symbol of German engineering power, proof that their side could build things no one else could even attempt. Its presence at Sevastopol boosted morale simply because of what it represented. At the same time, among Soviet defenders, rumors spread as well. They spoke of a supergun that could reach them from anywhere, a weapon that seemed untouchable. The psychological effect of not knowing exactly what was causing the destruction added to the fear. The Gustav was not just an artillery piece anymore, it was becoming a legend while it was still in use.
For all its power, the Gustav had a weakness that became more obvious with time. It was too much, too large, too slow, too demanding. Every shell required hours of preparation. Every adjustment took enormous effort. Thousands of men were tied to a weapon that could only fire a few times a day. Rail lines had to be prepared, guarded, and maintained just for its presence. In the same time it took the Gustav to fire a handful of rounds, conventional artillery batteries could blanket entire areas with sustained fire. Aircraft could strike multiple targets. Mobile guns could be repositioned quickly. The Gustav could do only one thing, and it did it slowly. Commanders began to realize that while the weapon was impressive, its contribution to the overall battle was limited. It was effective against specific, deeply buried targets, but once those were destroyed, its usefulness dropped sharply. The effort required to keep it operational began to outweigh the benefits. This was not something widely discussed at the time. The weapon's symbolic value and engineering achievement overshadowed its practical limitations. But quietly, among planners and officers, the questions started to appear.
By the time the Gustav was firing at Sevastopol, the nature of warfare had already shifted. The gun had been conceived in a pre-war mindset where massive static fortifications like the Maginot Line were seen as the primary obstacles to invasion. It was built to break walls, bunkers, and underground defenses that were expected to dominate future battlefields. But World War II did not unfold that way. Speed, mobility, air power, and mechanized forces reshaped how battles were fought. Front lines moved quickly, targets changed daily. Armies did not remain behind fixed fortresses for long periods. The Gustav was designed for a war of immobile defenses. It arrived in a war of movement. At Sevastopol, it finally found a target that matched its original purpose: deeply fortified, heavily reinforced, and difficult to reach. But this was an exception, not the rule. Most other battlefields did not present the kind of static target the gun required to be effective. This left the Gustav in a strange position. It was a masterpiece of engineering that had arrived too late for the type of war it was meant to fight. Its power was undeniable, but its relevance was limited to rare situations. The war had moved on, the Gustav had not. Wherever the Gustav went, an enormous logistical shadow followed. Rail crews had to prepare tracks in advance, engineers had to inspect ground stability. Supplies, food, ammunition, spare parts, and tools all had to be transported alongside it. Anti-aircraft units, security detachments, and maintenance teams were permanently attached. Moving the gun was not a relocation, it was a migration. Every kilometer of travel required planning. Bridges had to be checked for weight limits. Rail curves sometimes had to be rebuilt. Entire sections of infrastructure were adjusted simply to allow the weapon to pass through. This consumed time and resources that could have supported multiple mobile artillery units or air operations elsewhere. Once in position, the situation did not improve. The Gustav could not be packed up quickly if the front shifted. It needed time to disassemble, time to transport, and time to rebuild at the next location. In a war where fronts could change rapidly, this made the gun a liability. It demanded that the battlefield remain stable around it, something World War II rarely allowed for long. The Gustav was not alone. A second gun of the same design was built, known as Dora. Identical in size and capability, it represented the same ambition to dominate fortifications through sheer artillery power. But Dora never achieved the same notoriety. By the time it was ready for deployment, opportunities to use such a weapon were becoming scarce. The war was moving faster, fronts were shifting, and the kind of static siege environment required for a gun of this scale was increasingly rare. Dora was transported, assembled, and prepared, but its operational history was limited compared to the Gustav's experience at Sevastopol. This highlighted the underlying issue. Germany had invested enormous effort into creating not one but two of these massive railway guns, yet the situations where they could be effectively used were so specific that their presence became more symbolic than practical. The existence of Dora proved that the concept had been taken seriously at the highest levels, but its limited use also showed how quickly the realities of war had outpaced the purpose for which these weapons were designed.
As the war progressed, aircraft became more accurate, more numerous, and more capable of delivering heavy bombs directly onto fortified targets. What once required massive artillery began to fall within the reach of bomber formations. A bunker that demanded an 800mm shell in 1939 could, by 1944, be attacked by waves of bombers carrying specialized armor-piercing bombs. Aircraft could strike multiple targets in a single mission, change routes quickly, and operate without needing rail lines, cranes, and thousands of support personnel. Air power did in hours what the Gustav required days to prepare for. And it did it with flexibility. If a target moved, aircraft could follow. If defenses shifted, aircraft could adapt. The Gustav could do neither. It was locked to rails, locked to its prepared arc of fire, locked to a specific location. This did not make the gun weaker, it made it outdated. The logic that had once justified its creation, the need to destroy immovable fortifications from a distance, was being replaced by a new reality where aircraft could deliver similar destructive power without the enormous logistical burden. The battlefield had evolved beyond the need for a weapon that fired from one place at one target. The sky had become more effective than the rails. After Sevastopol, the Gustav was no longer seen as a critical military asset. It had demonstrated what it could do. It had destroyed the kinds of targets it was built for. But those targets were rare, and the war was moving in directions where speed and flexibility mattered more than raw destructive power from a fixed position. The gun still existed, it could still be assembled, it could still fire, but increasingly it was talked about more than it was used. It became a symbol of engineering ambition rather than a regularly deployed weapon. Soldiers spoke about it with awe, officers referenced it as proof of German capability,
But in planning rooms, its practical role in future operations was becoming harder to justify. Transporting it to a new location required time that commanders did not have. Preparing a firing position demanded stability that the front lines no longer offered. The Gustav had shifted from being a solution to a problem into a reminder of how much effort had gone into solving a problem that no longer existed. After Sevastopol, there were attempts to find new roles for the Gustav. Plans were discussed to deploy it against other fortified positions on the Eastern Front. Reconnaissance identified possible targets where deep bunkers and reinforced structures might justify its use. Rail routes were considered. Logistics teams evaluated whether it could be moved again in time to matter. But the reality of the front made these plans increasingly impractical. The war was no longer static. Soviet advances were rapid. Front lines shifted unpredictably. By the time the Gustav could be transported, assembled, and prepared to fire, the target area might already be irrelevant. There were reports of partial deployments and preparations that never resulted in actual firing. The effort required to set up the gun simply could not keep pace with the speed of the conflict. This was a stark contrast to its first use. At Sevastopol, the battlefield had remained stable long enough for the Gustav to operate. Elsewhere, the war refused to slow down for it. The weapon that required patience and preparation had entered a phase of the war that rewarded speed and improvisation. When people talk about the Gustav, they usually count shells, how many it fired, how far they traveled, what they destroyed. But the real cost of the weapon was not measured in ammunition. It was measured in time, manpower, and opportunity. Thousands of soldiers were assigned to support a gun that could only fire a few times a day. Rail crews, engineers, anti-aircraft units, security teams, mechanics, and logistics personnel were all tied to keeping this single machine operational. Those same resources could have supported mobile artillery, armored units, or air operations elsewhere. Fuel, steel, transport capacity, and engineering effort were all consumed by the need to move and maintain the Gustav. It demanded attention that could have been spread across many smaller, more flexible systems. The shells were impressive, but the infrastructure required to launch them was the real expense. And unlike the shells, that cost did not end when the firing stopped. For the soldiers assigned to the Gustav, the experience was unusual. They were part of something enormous, something that clearly impressed everyone who saw it. There was pride in working on a machine that represented engineering on a scale few could imagine. Many described the first time they saw it as unforgettable. But daily life around the gun was not traumatic. It was slow, repetitive, and technical. Long hours of preparation, maintenance work, waiting for orders, checking rails, inspecting equipment, coordinating movements that had to be exact. The moments of firing were rare compared to the time spent getting ready to fire. Some soldiers later recalled a sense of detachment from the actual battle. They were involved in the war, but from a distance measured in dozens of kilometers. They never saw the targets. They relied on reports to know what their work had accomplished. For many, the Gustav felt less like a weapon and more like an engineering project that happened to be placed near a battlefield. It inspired awe, but it didn't feel like the center of action. It felt like a massive machine operating according to its own slow rhythm while the war moved faster around it.
For Soviet defenders, the Gustav was something they experienced without fully understanding. They did not see the gun. They did not hear it fire. They did not know exactly where it was positioned. What they knew were the impacts, sudden, overwhelming explosions that seemed to come from nowhere and reach places they believed were safe. Underground depots collapsed. Fortified positions cracked open. Areas that had withstood days of bombardment were suddenly destroyed by a single strike. Rumors spread quickly among the defenders. Some believed the Germans had developed a new kind of bomb. Others thought they were being targeted by experimental weapons. The true explanation, an 800mm railway gun positioned far beyond their reach, was difficult to imagine without seeing it. This added a psychological dimension to the weapon's effect. The inability to locate or respond to the source of the destruction created a sense of vulnerability. There was no clear way to fight back against something positioned so far away and so heavily protected. For the soldiers under fire, the Gustav was not a piece of machinery. It was an invisible force that struck without warning and without explanation. As the war turned against Germany, the fate of the Gustav became uncertain. Moving it safely became harder. Allied air superiority made large rail movements dangerous. The front lines were unstable. The time required to set up the gun in a new location no longer existed. Eventually, the decision was made to destroy it rather than let it fall into enemy hands. Sections of the weapon were dismantled and blown up by German forces during their retreat.
What had taken years of design, engineering, and effort to build was reduced to twisted metal in a matter of hours. By the time Allied troops found the remains, the Gustav was no longer a weapon. It was debris, pieces of rail, fragments of machinery, evidence that something enormous had once existed there, but without the scale that had made it so impressive when assembled. The largest gun ever used in war ended not in battle, but in self-destruction, abandoned because the war had moved too fast for it to follow. The Schwerer Gustav was a masterpiece of engineering. It proved that humans could design and construct a weapon of astonishing scale. It demonstrated precision, metallurgy, logistics, and coordination pushed to their limits. It showed what was technically possible when resources and ambition were combined without restraint. But what it proved about war was something very different. It showed that size and power do not guarantee usefulness. The Gustav could destroy what no other weapon could reach. It could punch through rock and concrete from beyond the horizon. It inspired awe among those who saw it and fear among those who felt its impact. Yet it was slow, demanding, inflexible, dependent on conditions that rarely existed for long in a rapidly changing conflict. The war it had been designed for, a war of static fortresses and long sieges, had already passed by the time it was ready. The war it entered rewarded mobility, air power, and adaptability instead. In the end, the Gustav became a symbol, not of victory, but of how engineering brilliance can collide with the reality of a battlefield that refuses to stand still long enough for such brilliance to matter. It remains the largest artillery weapon ever used in combat, and one of the clearest examples of how the biggest solution is not always the right one.